Rajan sir, over to you.
Yeah, thank you, Atya. Thank you very much. Hi, everyone. A very good morning to all of you. I hope you're having an amazing day. Well, it's a beautiful morning here, and I'm really excited for today's session. So I am thankful to all of you for taking your time to, participate here in this live webinar on IPL predictions. So welcome back once again, guys. So here in today's session, let me share the agenda with all of you guys. So the agenda of today's session is basically IPL predictions. So yes, we are going to do some predictions today using machine learning. So I'll just take you through a tour of agenda here to keep the session practical. I have not included the PPT in today's session. The reason is because I wanted to discuss the practicals most. All right. So the agenda of today's session is IPL prediction using machine learning. So this is going to be an exciting session, everyone. So I hope everyone is excited and curious to know about how machine learning can help us predict the winning team here. So here, before I proceed further, I would like to introduce some fundamentals of machine learning here to the learners, and then I will be explaining the objectives of today's session. So how we'll be doing it, and we'll get started with the practicals. All right. So here I'm keeping the programmer's perspective as well as non-programmer's perspective in mind. So if in case if there is something technical, you are always free to do a small research over it. You can also talk to the technical experts at upgrad about knowing all those technical jargons. I'll try to keep it as simple as possible, and I'll be talking in a very layman's term. So first of all, before we start with IPL predictions using machine learning, so let us have a fair idea about what exactly machine learning is. In order to give you a fair understanding of machine learning, let's take an example here. Okay, let's take an example of grocery store here. Have you ever went to a grocery shopping store? I think the answer probably is yes. So what do you do before going to the market? Well, before you go to the shopping store, you always prepare a list of ingredients beforehand, and you also make some decisions according to the previous purchasing experience, right? And then you go to the then you go to the market to purchase some of the items. But nowadays you must be observing that the inflation is rising. Well, that is the other case why it is rising. But with the rising inflation, it is not easy to work with the budgets. Well, our budgets becomes imbalanced when we see price changes of the products. I have observed this many times. Whenever I go to market, my budget gets deviated a lot of time. This happens because the shopkeepers keeps on changing the either the quantity of the products, or they keep on changing the prices of the products depending on the supply and demand cycle. Now, due to such factors, many a times I have to modify my list. Yes, I have to modify my list because every time I see some changes in the quantity being offered of the products by the shopkeeper, or the price which is being quoted. Now, here, in order to buy these groceries with the rising inflation and the frequent changes in the pricing and the quantity of the products, it takes a lot of efforts. Actually, it takes a lot of efforts and research. It takes a lot of time to figure out exactly what we need to buy in the grocery items, and how much we need to buy. Well, I think all these questions can be easily answered with machine learning. Machine learning can tell you the probability that may occur in future. Machine learning basically studies the past data. Well, with the help of machine learning, we can predict what are the possible prices, or what are the possible pricing values of those products in the upcoming future. Yes, we can do that. So with the help of machine learning, what exactly we do? We exactly build intelligent systems. Yes, you heard it right. We build some intelligent systems that are capable of taking decisions on an autonomous basis. Sounds like a fictional movie. Well, this is true actually. Yes, the systems can take autonomous decisions on their own, right? And that's why they're called intelligent. But taking decisions, on their own is not the only thing that machine learning can do. Machine learning can bring various benefits, in an organization. For example, similar to our today's example, here we are talking about predictions. We can use machine learning for predictions. So, for example, let us take an example of, let's say, loan. Well, I think loan are very common across, all of us. And one or the other time, we might have taken some sort of loan. Now, now these financial institutions, can find that whether the customer is, probable to be a defaulter or not based on various parameters. With the help of machine learning, we can have a, greater level of idea about, about customers being defaulters. So these predictions of customers being defaulters can help the financial institutions and risk management. How about, the other use case, which is very much common among all of us, and that is image recognition. Well, image recognition is a very common, you can say, concept which is going on, among us. We can see the examples of image recognition, with the Face ID. I think if you're using the Apple phone, sorry. So, they use machine learning algorithms to detect the faces. Well, I'm not promoting iPhone here, but I'm really a fan of, the kind of work that Apple has done uh, with this image recognition, because it is almost very difficult to fool an iPhone system, to uh, detect you can say you can say a non-bio human, right? So I mean, we cannot fool a camera with just an image, right? So it is very powerful with the iPhone systems. Yeah, please ignore, this is not a promotion here. Okay. Apart from that, machine learning is heavily is being used with speech recognition. Speech recognition has become a very common activity, right? It has become a very common, you can say, exercise which we see in day-to-day devices. How about, when you say okay Google in your Android smartphone? How about when you say hey Siri in iPhone? How about using Alexa? So all these products are the results of speech recognition that is, powered via machine learning. Well, think of, all these products that are around us, they are powered by the same technology. Think of the changes that machine learning has brought to the world. Apart from that, the healthcare systems are using machine learning for medical diagnosis. Well, I have seen, certain systems, in some high-end hospitals where the machine learning is being used. Well, I remember one of the colleagues, which is working on this model basically, where, the automated emails are sent to the doctors, based on the, events or facts which are, being captured by the sensors inside ICU. So in the ICU, there are patients, with all those, sensors attached, and those sensors are sending the data into a central server where there is some machine learning system working and is notifying the doctors about the severity of the patients. Think about this, right? So this is pretty instant. This is helping the medical domain to, treat the patients on time and with with the appropriate response. So I think thanks to machine learning for all these changes which it has brought into the real world, so it is making or helping create a better world here. And it feels really great when we are part of such team. Apart from that, if I talk about one of the another domain, which is financial industry. Financial industry is using machine learning at a very large scale. So companies are using ML in fraud investigations and credit checks. Yes, you heard it right. There are lots and lots of financial institutions. You might have heard of CRED at least. CRED is something that is they are just flooding the advertisements, and I think that is one of the financial institution that we know in common, I think. So here, with these use cases, I hope that I'm able to convince all of you with what a machine learning can do, with all its features, or what products can are produced using this concept or technology. So how exactly it works, right? So if we talk about machine learning here, so how exactly it works? If you want to understand the working of a machine learning, I'll just give you a simple execution flow here, which will help you understand the flow of machine learning. So machine learning cannot work without data. Well, data is the input, for machine learning. So the machine learning systems learn from the past data, right? If we do not have the past data, the machine learning cannot work. So input the past data. So once we input the past data, the machine learning actually models learns from this data. So how exactly it looks like? So there is some machine learning algorithm which will be written, right, or which will be using. So there will be this machine learning algorithm, right, which will be reading this data and will be building the logical models. So there is something called models here, which we generate um, in this system here. So here we'll be generating some logical models, and these logical models will further be producing the output for us. Well, if you're a non-technical learner, you can simply, enjoy this tour. It's not necessary to go into that much detail. I just wanted to, expose you to the flow, right? Flow of, how the machine learning works, right? So here, if I give you a simple summary about, what is happening here, the summary is that, machine learning uses data to detect the various patterns in the provided, data set, right? So it can machine learning basically learns from the past data, right? And with every learning, with every algorithm, it keeps on improving itself. The core of this discussion is that machine learning is completely a data driven technology, right? So here it is a data driven technology. So when we create machine learning models, there is a sequence which is followed, which I would like to share with all of you. So yeah, there is a sequence which we follow during machine learning implementations basically. So first, whenever we are creating a system which is machine learning enabled, so first of all we have to define the objective. So exactly what is the objective that we want to serve, or that we want to serve by the model that we're creating. Once the objective is clear, that what we want to do, the next step would be to collect the data, which will be used for training the models. Before we create the training models, training and testing and training models, we are supposed to do some sort of data pre-processing. We need to clean the data, right? If we do not clean the data, then we might see some inappropriate responses by the models. For data pre-processing, we can take help of visualization of the data, which will help us understand where the outliers are or where the anomalies are. And then we will create the training and testing algorithms or the models, and we will run these models, and based on the running of these models we will collect the feedback from these models, right? So what the model has to say about the prediction, right? If we see that the accuracy or the accuracy percentage is less, then in such cases we need to refine the algorithm, right? So it is not like that, that in just one attempt, everything will work as expected. No, it is not like that. When we do the predictions, not every time we will get the exact results, and not every time the prediction is 100% correct. Yes, it is the part of machine learning. In most of the times you will find that the accuracy is not coming close to 100%. So that's where we need to refine the algorithm. So it is an iterative process. When you create machine learning models, when you create machine learning system, I would say it is an iterative process, and in every iteration we are supposed to improve on the algorithm, and that's how we'll improve on the accuracy of the data. Well, the idea here is not to teach machine learning here. The idea is to give you a fair understanding of what exactly we do in machine learning. Well, here we can categorize machine learning into various segments. Here we can say supervised machine learning. We can talk about reinforcement based learnings, and we can think of unsupervised learnings. Well, these are some of the learning models which are followed under the machine learning umbrella. The idea here is not to explore machine learning a lot in detail, but just to give you a fair understanding of what different kind of learning models are here. Well, this is what I wanted to share with all of you in this given time period, and I hope I'm able to provide you with a fair understanding of what machine learning is doing, to the data, and what are the products of this given technology. Well, with this, I'm concluding this particular part here of machine learning introduction. Now, let us get back to the IPL prediction using machine learning, and let us understand what exactly we are going to do in the predictions here. All right. Here, I've got some data with me. I've got the data of the matches here. So, if you observe here, okay. So here's the matches data, right? Just give me a moment. And if you look at the season here, I think it is pretty clear to all of you that how many seasons are included here. So I've got this data in which the seasons are from 2008 till 2019, and we have got the results. Who won, which team won, whether it won by wicket or whether it won by run, or if there was a tie. So everything is here. Everything is here in this data. So it's a long list of records here. Now this is a data of seasons, you know between 2008 till 2019, right? So I'm repeating here myself once again. This is the data of the patches between 2008 to 2019. Now what are we going to do here, right? So what exactly is the objective here? So here I have got this one more file here called matches of 2020, right? So here the this is the data which basically is about the details of the matches which were conducted in 2020, but here there are no results, okay? But if you observe here, so guys, do you see any results here, like which team won, which team lost, whether it won by wicket or whether it won by run? Do you see such details here, guys? Yeah, everyone, thank you very much. Thank you, Georgian. Okay. So you guys are absolutely right here. If you look at this, data here, there is one thing that you will find here is that we have the teams here. So we can see that on this state, these two teams are going to play, right? And on this state, these two teams are going to play. Similarly, these two teams are going to play on these dates. So here, the objective is to predict that based on the data which were played between 2008 and 2019, right? Based on this data, where the teams played between 2008 and 2019, we will create a model which will learn from this data and will tell us the probability that in 2020, if these two teams are playing against each other, then which is the probable team which is going to win the match. All right. So here we are predicting that which team is the or would be the probable winner if these two teams are playing, and we will be able to tell this prediction because of the matches which were played in the 2008 and 2019 year. All right. So guys, could I can I confirm from all of you, right? Are you clear about the objective of this model here? Are you clear about the prediction? What are we going to predict here? Okay, that's great. That's great. So what are we going to do here, right? So let us start with some action, some coding action. All right. And okay, so here I'm going to create a new notebook here, and let us write some codes here, and let's see exactly if we can predict the winner here. Yeah, George, and thank you very much. That is exactly the right answer. So here, when we are starting with machine learning, so I will simply say IPL prediction using machine learning. So here is a notebook, and for machine learning models, what I'm going to do is, first of all, I'm going to import the necessary libraries which are required for predictions. All right. So just give me a moment. Import numpy as np, import pandas as pd, import os, import cborn as sns. Well, it might look crazy to you that we have to prepare so much masala to get that prediction, but it is worth doing it. Okay, so from sklearn dot model underscore selection, import train test underscore split. So here I'm importing some of the libraries here. I think this is taking a lot of time for me to type this. So let me bring this here. Okay, so here you can see some ingredients. All right, don't get scared, don't get afraid. All right, so these are the helping hands, these are the supporting tools which I'll be requiring for predictions. All right, some are algorithms and some are classifiers, some are label encoders, some are data visualization technologies, and some are for data analysis. So all these things combined are going to help me do the predictions. All right. Okay, so this is how exactly it looks like. So here, let us let us load the training data first of all. Okay, let us load the training data. All right. So first of all, let us prepare the training data here, right? So I'm going to say training data equals to pd dot read underscore csv. I'm going to say training um, training matches IPL, right? 19 CSV. Okay, training matches IPL 2008 hyphen 2019 dot CSV. All right. Oh, come on! Don't do this to me. Okay. So let us preview the data here. So this is going to be train data dot head, So before I proceed further, I just want you to have a look at the data here, everyone. All right. So this is exactly the same thing which we did yesterday, almost same. You can say we have the details of the team, the toss winner, the decision, win by runs, win by wickets, and so on. All right. So this is our training data, and we'll be using this training data for training our machine learning models. But there is one thing that you must understand, that whenever you're working with data, you need to check the you know data quality. Okay, so checking the data quality is very important. Here I'm talking about handling the missing values. All right, so handling missing values is a very, very important factor when it comes to creating the machine learning models, because if there is any anomaly in the data, if there is any noise in the data, then your models which you will be creating will not be producing the accurate results. All right, so here, as part of data pre-processing, we are going to check if any null values are present, in the data here. So here, I'm repeating myself once again. Before we proceed with the machine learning models, let us prepare the data first of all, right? That is a very important aspect. So here, I'm going to check for the null values. Do you see the null values here in the columns? Please ignore umpire 3. Right, umpire 3 is something which will not be counting as a parameter for winning, so you can ignore that as of now. But what are the other columns do you see here which has the null values? Yes, that's right. We see the city here. City has 7 null values, and then yes, we see the winner. So winner is another field which has null values, and you will also see the same in the player of the match. Now we have to do something for this, right? We have to do something for these missing values. Now first of all, let us take care of this field. All right, city. So here, this this analysis is telling us that in the city field there are 7 null values. Well, I really want to see what these matches are where the city is not available. All right, and we'll try to figure out what can be the probable city which we can impute here, or which we can use to replace the nulls. Okay, the idea here is to replace the nulls. All right, so as part of missing value treatment, what I'm going to do is I'm going to replace the nulls with the probable city title. But here, first of all, before we assign the city title, we need to figure out exactly what city it is where these matches were played. So let us find the details of matches where the city is null, right? So for this, I'm going to say train data city is null. All right. So guys, here I will be requiring your attention. And so do you think that the city is null here? Observe the city field. Here it is, right? Here it is. Yes, the city is null here, okay? And the objective is to replace these nulls with the, appropriate value here. So we are going to impute a value here in this column, okay? So here, if you look at this details, look at this venue here, guys, okay? Look at the venue. So by looking at the venue, will you be able to figure out that what should be the probable city title which we can add, right? The city title. What is the probable city which we can add here? Mm-hmm. Mm-hmm. Okay. All right. Really? Uh, I think Dubai is a very good choice, but my response to all of you would be Abu Dhabi. Okay, but it is you can figure out later why I'm saying Abu Dhabi. All right. Okay. So so here we figured out that we will replace city null values with Abu Dhabi. All right. So this is a curiosity, which I'm keeping alive. That why I'm saying Abu Dhabi here. All right. The next field I've not done this updation. I will be doing it. Okay. Let's keep it open. The next uh, attribute which I can see here is the winner, which has four nulls here. Okay. Now here I'm going to figure out that why the winner values are null here, and what is the possible value which we can use to impute the nulls or replace the nulls. All right. So I have not done the updations, guys. So train underscore data equals to train underscore data winner is null. So guys, here you can see everyone that it says winner is null here, right? Winner is null here. So what do you think, guys, right? What is the possible value which we can use here to replace the nulls in the winner attribute or winner field? Anyone? Are you observing the data closely? Come on, guys, you can do this. What is the possible value which we can use here to uh, replace the winner? Are you observing the win by runs and win by tickets both? Are you observing these two attributes here, win by runs and win by wickets? So what can be the possible case here which we can use, to impute the nulls here? Come on. Mm-hmm. Okay. Yes, Georgian. I think I would like to, agree with Georgian here. I would like to call it a draw, or yes, Rishi, that's absolutely right. We can call it a tie as well. All right, but we have to agree on one value, one imputation value. So I would like to call it a draw. All right. So sorry. So here in this segment, we learned that how we can find the anomalies in the data, or I mean to say the missing values, and how we can figure out the right or probable value which we can be used to impute the nulls here. So let us complete this imputation and let's update the uh, data frame. All right. So I'm going to say train data city dot fill na, and I'm going to fill NA with Abu Dhabi, and I'm basically updating the data frame. All right. Well, at least my today's session learners DSC 30 knows what in place is and what fill NA is. We just did this today only in one of the program, and I know that there are some learners here. Okay. So here I'm replacing the nulls with the draw here. All right. So, yep. Let's check once again here. Let's check the statistics here. So I'm not working on player of the match because I don't need that as of now, right? So in order to keep the session short and to the point, I just did two attributes imputations here, but we can work on the other attributes as well, keeping the session duration in mind. I just did some examples here just to make you understand. So here, if you look at these statistics here, if you look at these facts here, we have handled the missing values, and there are no missing values in the city field and the winner field. All right. Now there is one more thing that we need to understand here. Okay, and what that is. Uh, Let us observe the teams, right? If they are correct, because here in the next lab we are going to observe the team basically, right? I'm talking about Mumbai Indians or Chennai Super Kings or Kolkata Knight Riders or Sunrisers Hyderabad, because I remember from my study or from my experience that some teams left IPL, or some teams were there who were part of IPL initially, but later they withdraw from the IPL team. Some teams joined later in between, and some teams got their names renamed, right? So do you know any of the team in the IPL which got their title renamed? Anyone? Yes, Georgian, that's right. Yeah, that's right. That's right, Georgian. So Vaibhav is saying Punjab. I think that is Kings 11 Punjab got changed to Punjab Kings there. All right. So here, let us check if we have the right team in the data frame. Yeah. Thank you, Georgian. Yes. Thank you, Vaibhav. Please repost to attendees also. Okay. Okay. So guys, here, look at the team titles here, and do you think that we have the right team titles here? Or do you think that we need to do some changes here? Anyone? Do you see some sort of anomalies in the data here? Yes, George, and that's right. There are a few changes which are supposed to be made here. For example, anyone? Look at this anomaly here. This rising Pune supergiant is repeated twice, but there is a small difference of S here. In one case, it is rising Pune supergiant, and in the other case, it is rising Pune supergiants. All right, so we need to rename this. Do you see any other changes here? As per the responses, I think Deccan Chargers are supposed to be replaced with you know uh, Sunrisers Hyderabad. Well, I agree with Rishi Jha as well. Well, Delhi Daredevils are supposed to be changed with Delhi Capitals. All right. Well, that sounds pretty great to me. I'm really happy to see the responses. That's really awesome. All right. Let's do the replace job here. Sorry. So here, I'm going to get these titles replaced, and let us see if this is working for all of us. All right. So here's the small magic. Okay. No, it is just a copy and paste. So here, this is train data dot replace. So here you can see that I'm making some changes here. I'm making some replacements, right? So Rising Pune Supergiant is getting replaced with Rising Pune Supergiants. Deccan Chargers is getting replaced with Sunrisers Hyderabad, and Delhi Daredevils is getting replaced with Delhi Capitals. Well, if I'm not wrong, I remember that Deccan Chargers and Sunrisers Hyderabad are two different teams. If I'm not wrong, guys, please correct me on this. Right? Deccan Chargers withdraw from the IPL, and then after some time, Sunrisers were there. I think these are two different things, if I'm not wrong, right? I just remember a little about this. Okay, let us check if we have corrected the anomalies in the data here. So here, oh come on, don't do this to me. Okay, now it is done. Okay, now here we can clearly see that the rising Pune Super Giants is corrected. We can see the Delhi Daredevils is changed to Delhi Capitals, and mm, we can see here what's that? Deccan Chargers is not there, and we have Sunrisers Hyderabad. Well, well, there is one thing that we have not changed here. Yes, Vaibhav, I also heard that sort of thing. Well, it is a pretty complex thing. All right. Okay. Well, guys, anyone has any idea about why we did not change Kings 11 Punjab to Punjab Kings? Anyone? Why we did not do this change here? I think this is also supposed to be changed. Do you think? Do you think that we need this change here or no? Okay. Oh, all right. I think we have some good followers of IPL here, and that is 100% right. This title of Kings 11 Punjab got changed in the Feb 2021. Well, this is the data till 2019 and up till 2020 actually. That is why we don't need to do any changes here. All right. Let us find some insights from the data here. So let us find the total number of matches, played. So played. All right. So here, I'm basically trying to find the total number of matches played between 2008 and 2019. All right, as per my data. Okay, so okay, so PLT dot subplots. I'm going to do some visualization here. So SNS dot count plot x is I'm going to count the season actually, right? So here the parameter for finding the number of matches played is you know the season, and this is just cosmetics actually, the palette. And I'll just add the title here: total count of matches played in each season. All right, plt dot show. Well, I think it is pretty understandable. If you look at this data here, it's pretty understandable. We can see that we did this yesterday also, right? So in 2011 and 12 and 13, this saw most number of matches actually, right? Even 17, 18, and 19 are quite uniform. Rest of the years are quite uniform actually. So yeah, okay, then that looks great. All right, so I think I need to make it a little bit better here. Let's make it visually a little bit better. So yeah, just give me a moment, guys. I am just adding some titles here. Hmm. Because these bars are not very much clear to me actually. I'm not able to see the values properly. So I am just trying to get some values on top of these bars actually. Hmm. It says invalid syntax, but that's fine, right? That is a part of your day-to-day programming, so we have to accept this. Let me correct this thing. What I'm missing here. Hmm. Oh, looks like there is this extra comma, which is a little annoying here. So I will just correct this extra comma, and this should work now. Hmm. All right. So this one is more understandable. This one is you know uh, pretty you can say interpretable, that what are the exact values here. So I just applied some cosmetics here, just to interpret data a little better here. Okay. Now at the same time, what we can do is we can also predict the winning teams as well, right? the winners actually as per the past data. So here, if you look at this implementation here, you can clearly see the winners, right? The winning team, you can say, since 2008 uh, to 2019. So here, this is as usual. We saw the same details in yesterday's session also. Mumbai Indians were the topper, and we had a lot of fans on, we had a lot of fans for Chennai Super Kings also. Yes, in yesterday's session, I don't know how many are there today. And then we have KKRs and Sunrisers and so on. All right, so this is just you can say analysis that we are doing, that which is the most winning team till now, and how many matches are played. So these are just a part of analysis and visualization here. Okay. Now, what is the next thing that we are going to do here, right? So the idea here is not to do just visualization. The idea here is, to uh, make the predictions, right? To do the predictions exactly. So here, there is one fact that everyone must understand, that machine learning models works with numbers, right? Machine learning, I'm repeating here myself once again, machine learning models works best with numbers compared to labels, I mean to say strings or the characters. So in the next exercise, what you will see here is I am basically you know uh, I'm basically converting the values into integer forms, right? So here I've done some encoding here, right? So this is a logic which I have followed here. So what this logic does, I'll give us a fair idea about this, okay? Do not worry, all right? So here the KKR, right, is given numeric to value 1. So you can see here, right? So 1 is KKR, right? That is Kolkata Knight Riders. Then who is this 7 here, right? This 7 is RCB, that is Royal Challengers Bangalore, right? So what I have done here, I have given some numerical representations to my teams, right? So what is the reason behind doing this? The reason for doing this is we want to change the you can say labels into numeric forms, all right? So this is what I have done here. So here I would like you to observe team 1, team 2 in numeric form, as well as the winner in the numeric form here. And you can see the toss winner as well in the numeric form. But this is not the end of this model. What are we going to do here is we are also going to extract the fields which we require for creating a training model, all right? Extract the relevant fields, right? Which I'll be requiring for creating the training model here, right? So this data frame has lots and lots of attributes which I don't require for creating a training model. Now in the next lab, I'm going to filter the attributes and extract only those attributes which I need for my prediction purpose. So here, if you look at this demonstration, if you observe this code snippet, well, what I have done here is I have extracted only those fields which are relevant to me for sorry, for creating the training model here, right? So here I have just get rid of those unnecessary attributes. Now here I'm going to work on a new data frame called train, right? So train is the new data frame where we will be working. Okay, so here this is my training data, and there is one thing that you can clearly see here is in this data frame still there are some attributes which are categorical. I mean to say there are some attributes which are you know uh, you know string format. Yeah, George, and thank you very much. Okay, which are of string format, right? So what are those columns here which you see here which are of string format here? So the idea here is to convert this whole data frame into a numerical format. Okay. The idea here is to convert this data frame into a numerical representation. So we have city, we have toss stations, we have venue. So what are we going to do? We are going to convert this, right, fields into numerical representation. All right, and for this purpose, here I'm creating a subset here. Everyone please observe. So train is the train is a data frame which we created, and we created a replica of train here, which is df. All right, I'm repeating here, df is a replica of train data frame. Okay, df is a replica of train data frame. So here I created a copy of the same data frame. All right, and sorry, now here I'm using something called label encoder, right? So what this label encoder does, label encoder is somewhat similar to binning in pandas, right? So if you know what binning in pandas, it will be easy for you to understand. Well, this label encoder will convert my categorical fields or string values into integer representations. All right, and there is this new data frame which is getting created. This is df, right? So I'll just show you the df here. So thanks to label encoder, due to which with the help of label encoder, I'm able to convert these values you know uh, into the numerical representation. And if I show you the data types here of all the fields here, you can see that all the fields are successfully converted to integer representation, because machine learning algorithm requires numerical data to work upon for better results here, I would say. Okay, so here we have this df with us, which has all the numerical data with it. Now, what else we are going to do here? We are going to standardize it, right? We are going to standardize the values, right? We are supposed to scale down the values actually. So here, sorry, here you can see that I'm using standard scaler here, right? So standard scaler is something which will scale the values down, right? Because many machine learning algorithms, they work better when these features are on a small scale, right? So here the idea is to scale down the values from the big numbers into the smaller range. And this is a smaller scale values, and they are closely distributed actually, right? So they are closely distributed. So this is required because many machine learning algorithms perform better when these values are relatively smaller and are normally distributed. So there are some algorithms such as logistic regression or linear regression, nearest neighbors, or neural networks. They work. They find it easy to work with. To produce results with these relatively small values. Yeah, I understand that this might look weird to the new learners, but this is how exactly it works. All right. Now, what are we going to do here, right? So here we are going to try different algorithms, right? Yes, you heard me right. Let us try different algorithms, right? And let us see, you know, uh, what is the accuracy score produced by these algorithms. So I'm using logistic regression here, I'm using random forest classifier here, XGB classifier, k neighbor classifier, Gaussian, I'm using distance tree classifier here, I'm using svc here. So these are different machine learning algorithms that we can use to make the predictions. The best part about this algorithm is that they also tell the accuracy of their output, right? Whether the output is 100% accurate or 80%, 50%, 20%. So we will see the results here. So just give me a moment. So this is running. So there are a lot of warnings coming up here. So let me clean this clutter. All right. So just give me a moment. I'll just clean this clutter here. So, okay. So here, my models are running, right? These algorithms are running. And if you look at the output here closely, you will find that every algorithm here is giving some accuracy score. So, guys, would you be able to figure out which algorithm do you think are giving the best scores here? According to you, look at the accuracy scores here. And which algorithm do you think is giving the best score here? We'll be using that. Hmm. Hmm. All right. Amit, that's great. Georgian, that's beautiful. Come on, keep observing closely. Yeah, observe closely, guys. Hmm. Key neighbors also. Okay, Harshita. Decision tree classifier, that's great. Hmm. Okay, so here we can see a random forest, we can see XGB, we can see a decision tree classifier as well. They're giving us the best accuracy here. Now, this is the time to prepare the testing data. Okay, so we will validate training data against testing data. The next section that you will see here with me is basically the testing data, right? Okay, now please have a look here. So, guys, this is where I would like you to focus on. All right, so from which file I'm picking the testing data? All right, so did you observe the dataset name here, the dataset which is being used here for preparing the testing data here, right? So it is test set matches of 2020. Now, do you remember I showed you that in the 2020 IPL matches, I don't have the winning results with me. All right. So this is the testing data. This is IPL 2020. And if you observe the testing data here, training data here, so this is the training data, which is the past data of matches from 2008 to 2019. So there is a difference, right? So it's a training data, it's a past data, and if we go to the bottom, this is a testing data which doesn't have results in it. So it is IPL 2020 data. All right. Okay. So this is the testing data frame that we have created. Now this is the time. Sorry, this is the time to test our model. All right. So here, sorry. So here I'm going to test my model, right, against training and testing data here. All right. Oops. Just give me a moment. Yeah, Georgian, 100% right. 100% right. We are supposed to do that. Okay. Yeah, just give me a moment. Yep. Where is yep, just give me a moment. I think there is some correction which is required here. Hmm. Okay. All right. I think I need to rerun this notebook, guys. Just give me a moment. So there is this kernel which is troubling. I'll just restart the kernel. All right. So here you can see, guys, that you know this is the testing model validation which I've done here. I know that this is a quite creepy code. You can ignore this as of now, but here I would like you to look at the results of predictions here. All right. So here what I have done, I have added a new field here called winner, right? So this is the predicted winner. Okay, I'm repeating here myself once again. This is the predicted winner. Okay, so if there is a test, if there is a match between Mumbai Indians and Chennai Super Kings here, right? So who is the probable winner as per the past data? So it says that Chennai team will be the winner, right? So guys, could you please confirm me the match which happened in September 19 in 2020 between Mumbai Indians and Chennai. So, which team was the winning team? Could you please confirm me this fact? Yeah, Georgian, that's right. Winner is a predicted win model, right? Predicted winner here. This is the predicted output. Could you please confirm me which team won uh, on September 19, 2020 between MI and CSK? So let us check if the prediction is right. Anyone? Georgian, really? Don't let me down. Hmm. Uh, let me let me verify this. So, who won 19 September 2020 IPL match? Right. So this is IPL. Please ignore that. All right. So I think this is CSK, right? That is yeah, Chennai team. So is the prediction right, guys? What do you think? It says CSK here and it says CSK here. Is the prediction right? What do you think? Yes, George, and thank you very much. Yes, CSK is right. Okay, so well, but I would say here that machine learning models do predict the probability of the winning team or any winning factor or any factor that you're looking for. But I would say that creating machine learning models is a iterative process, right? If you check different details, you will find that in some places the prediction is wrong, right? This happens also. This is not 100% right. That's where we need to keep on improvising the models. All right. Okay, so that was all from my side on IPL prediction using machine learning today. I hope today's session was fruitful for all of you. I hope I'm able to make you understand that how using machine learning you can predict the expected output and yes, Georgian, I saw that, right? So and how this technology is helping the world create a better place to live. All right, guys. So that's all from my side, guys, for today's session. Everyone, I'm thankful to all of you for joining me in today's session. I'll surely see you in the next week with some more predictions and with some more parameters to chase the winning team. Thank you, everyone. Thank you very much. Stay happy, stay blessed, and stay safe as well. Bye bye, everyone. Take care.
Guys, do fill the feedback form before we wrap up the session.